Alright, I just want to start out by saying if you've got any questions, you can write them here, and I'm going to drop a piece of personal information as audio check. You can write it right there when you get to it. So, radical notation and rational exponents. This is section R-7. I want to start out by saying it might be worthwhile to memorize what the perfect squares are. 1 squared, let's see, 1 squared, 2 squared, 3 squared, 4 squared. This is 25. 6 times itself is 36. 9 times itself is 81, 12 times itself is 144. It's just good to have those memorized and kind of off the top of your head. Same thing with the perfect cubes. If you don't have them memorized already, similarly, we've got the perfect cubes. We've got 1 times itself 3 times, 2 times itself 3 times, 3 times itself 3 times, 4 times itself 3 times, 5 times 5 times 5, 6 times 6 times 6, 7 times 7 times 7. And they usually don't go higher than that in this textbook. So let's simplify. Problem number 1 asks you what times itself is 9, and that the answer is 3. 3 times itself is 9. We're only going to consider the positive square roots in this case. So what times itself is 144? That's going to be 12. And you just bring down the negative sign in this case because it's outside of the square root. The square root doesn't apply to the negative sign. You just bring it down. Number 3. What times itself is negative 36? Well, that's kind of different because negative 6 times itself is still 36. It's still positive. And 6 times itself is still going to be positive. So actually there's no easy number that you know of so far that we're going to talk about that when you multiply itself you get negative 36. So there's no real answer. There's actually an unreal answer, or an imaginary number that is the answer, but for right now I'm going to say there's no real answer. No real number times itself is going to give you a negative 36. That's a little different from the cube root of negative 8. You have to ask yourself what times itself 3 times is negative 8, and you can just say it's negative 2. Well, checking it, you can say negative 2 times negative 2 times negative 2. That is going to be 8, and 2 of these are going to cancel out, but you're still left with 1 of them. So that's negative 8. What times itself 3 times is negative 8? That's negative 2. That's the answer. So just to summarize, when you are using when you're using a regular square root, or even when this number is even, then you can't have negatives and get a real answer. But when it's odd, you can. You can get negatives inside the radical and still get an answer, a real answer. What times itself 3 times is 125? That would be 5. 5 times 5 is 25, times 5 is 125. I want you to do number 6, so pause it, and then ask yourself what times itself 4 times is 81. I hope you get the answer. We'll talk about it in class. Next, what times itself 4 times is going to be negative 16? Well, I could try and say that it's negative 2. Negative 2 times itself 4 times would give us 16, but it would give us positive 16 because all of the negatives cancel out. So really there's no real answer. No real number. No real number, no real answer, same idea. Now, number 8. What times... Whoa, we got a fraction? Well, the great thing about fractions is that you can really just split them up into numerator and denominator and handle them separately. So what times itself 5 times is 32? The short answer is 2. And then what times itself 5 times is 243? It's 3. So the answer is 2/3. Moving right along, we've got number 9. Now here, what we have to do is we have to think of this as like parentheses inside parentheses. So let's do what's inside the parentheses first. Negative 4 squared is 16. So really this is going to be the square root of 16, which is just 4. Notice it started out as negative it went from -4 to +4. We're going to return to this in a second. Let's see. The cube root of -5 cubed. Let's do what's inside the parentheses first. This is going to be a cube root of -5 times -5 times -5 is -125. And when you take the cube root of that, what times itself 5 times is -125? Well, that's actually going to be -5. So here it went from negative and it stayed negative. The cubing and cube rooting of it didn't affect the sign, it just stayed negative. And what we can say in general is that if you have an odd radicand, then the sign is going to be unaffected. However, if it's even, like in this case, it's a 2, you're asking what times itself is 16. What times itself twice is 16. You go from negative to positive. That's very much like an absolute value. So what you can say in general is that if n is even, then this simplifies to really just saying what's the absolute value. Remember, it went from negative to positive. It's very much like just absolute values. And if it's odd, then you can say then you get what you see right here and in your notes, which is r to the n. The nth root of r to the n is just r. It's the same thing as right here, just without the absolute values. So when it's odd, no absolute values are necessary. Here, you can see that we've got 4th root of 4 and the 4th root of 5, so you can combine them to get the 4th root of multiplying, you get 20. Here, the square root of 50 actually can be split up into a perfect square factor of 50, which is 25, and the square root of 2, because 2 times 25 is 50. You take the square root of 25 and you get 5, and then bringing down the square roots of 2, you get this. So 5 root 2 is your answer. This is actually a simplified version of square root of 50. If you checked on a calculator, they'd have the same decimal equivalents, but this is just a more simplified version because what's inside the square root is a smaller number. Okay, square root of 72 over square root of 6. Well, I think what we can do here is we can just combine them into one big fraction. 72 over 6, that just simplifies down to 9. Square root of 9, and you ask yourself what times itself is 9? That's 3, which is the answer. Here, one little trick that you can use actually is this trick. You can bring the exponent out. And that's going to be hugely useful here because when you take the 5, you bring it out, that becomes the cube root of 8 all to the 5th power. Cube root of 8 is actually way easier to calculate. What times itself 3 times is 8, that's just going to be 2. Inside the parentheses to the 5th. 2 times itself 5 times is 32. Let's simplify these. We've got the square root of 3 different things. I'm going to split them up. 2 square root of 216 times the square root of x to the 5th times the square root of y to the 3rd. So what I'm going to start doing is I'm going to try and, none of these are perfect squares, but I can find the factors of 216 and try and find the largest perfect square factor I can. The factor pairs of 216 are 1 and 216, 2 and 108, 3 and 72, see, 4 and 54, and see, 5 and, no, not 5, 6 and 36. And then it's going to keep on going. There's lots more factor pairs, but I don't think I'm going to get any larger than 36 as a perfect square factor. So I'm going to rewrite square root of 216 as the square root of 36. That's my perfect square factor. And 6. Simplifying, we get 6 square roots of 6. Now let's do the same thing for x to the 5th. Really, you can think of x to the 5th as 1 times x to the 5th, or x times x to the 4th, or x squared times x to the 3rd. And the largest perfect square factor of x to the 5th is going to be x to the 4th. Square root of x to the 4th times square root of x to the first power, or just x. When you take the square root of x to the 4th, what times itself is x to the 4th? That's x squared times the square root of x. Let's do the same thing for y cubed. Y cubed is really 1 times y cubed, and then y times y squared, and then we'll do y squared times y. But really the largest thing, the largest perfect square factor is going to be y squared. Square root of y squared times y, the square root of y. And when we can simplify this and get y times the square root of y. So recollecting all the numbers that are outside of the square root, we get 6x squared y, and collecting all the numbers inside, we get times 6xy. That should be the answer. Here, I'm going to say that we can split this up into a fraction. We get a square root of x squared over square root of 16. Square root of x squared, we've already seen before, is going to be, you might think that the answer is x, but actually be careful because it's the absolute value of x. No negative number you put in for x is ever going to stay negative. It's always going to turn into the positive version. So this is our answer. Next problem, we've got to combine the like terms, and this might not look like a like term to begin with, but I think if we find the perfect square factor, the largest perfect square factor of 20 is going to be 4, and 4 times what is 20? That's 5. Bringing down the 8, it's there. So let's recopy, and we find that we've got some common terms, especially after this simplifies down to 2. So we've got 7 of these plus 3 of these minus 8 times 2 is 4 of these. 7 plus 3 minus 4 is 6. 6 square roots of 5. Moving right along. Let's simplify what we see in the square roots. This is going to be 3 times square root of 8 times square root of x squared, just to split them apart a little bit. Square root of 2 times square root of x squared. Well, the square root of 8, there's a perfect square factor, and that's 4. Square 4, 2, 3. Square root of x squared is absolute value of x minus 5 square roots of 2 times, again, absolute value of x. This simplifies to 2, so we really have 6 times 2, 6 times the square root of 2, absolute value of x, minus 5 square roots of 2, absolute value of x. So 6 of all of these minus 5 of all of these is just 1 of these, so you're left with square root of 2 times the absolute value of x. And often in the answer key you'll see that they want to make sure that the square root of 2 is just the very last thing, so I'm going to rearrange the order. So it's absolute value of x times the square root of 2. Moving right along. Here, this looks like something we can FOIL. And the first terms are going to be these two. Square root of 3 times 2 square roots of 3. Square root of 3 times 2 square roots of 3. When you multiply these together, you get square root of 3 times square root of 3, which is 3 times 2 gives you 6. And outside terms, square root of 3 times square root of 2 is going to be square root of 6. Inside terms, you've got these two. Square root, let's see, that's going to be negative 5 times the square root of 2 times 2 times the square root of 3. Negative 5 times 2 is negative 10. Square root of 2 times square root of 3 is square root of 6. Last terms, we've got these two here. That's going to be negative 5 times the square root of 2 times square root of 2. Square root of 2 times square root of 2 is 2, times negative 5 is negative 10. We can even combine a couple of these. Square root of 6, 1 square root of 6 plus negative 10 square roots of 6 is negative 9 square roots of 6, and 6 plus negative 10 is negative 4. And that is our answer, negative 4 minus 9 roots of 6. We've got a word problem here. And right before I read this word problem, did I mention that I met my wife, or I started dating my wife when we were in a high school musical? If you've ever been in a high school musical, you've probably seen that happen. People get together over high school musicals, and so why don't you tell me if you've ever been in a musical in class, or how you met your girlfriend. So that's the personal information. You can write it down in the audio check. How long must a wire be to reach the top of a 14-meter telephone pole to a point on the ground 7 meters away? If I'm going to redraw this triangle right here, it's really going to look like this. To a point 7 meters away, 14 meters high, how long is the wire? There's the knowns and the one unknown. They're related like this. 7 squared plus 14 squared is equal to, I don't know what squared. If you multiply that out, 245 is equal to c squared. So taking the square root, we get c is equal to approximately 15.7 meters, more or less. That's the answer. I'll see you in class. Oh, I almost forgot. Take the extra bit of time you have right now to start assignment RG. I want you to write the assignment, the problem list up at the top of the next page in your composition book, and then just start the first problem and bring it all to class. I'll see you later.